Welcome back to my channel. We all know that most of the variables of interest are generally quantitative in nature or continuous in nature, but sometimes qualitative, categorical, or enumerative data also arises in the research, like when we are doing the characterization studies. To deal with such type of data where the variables are not quantitative, rather they are qualitative, categorical, or enumerative, for that we have a very important test of significance that is known as chi-square test, which falls under the category of parametric as well as non-parametric studies. Well, in this video we'll be doing a very basic analysis regarding one of its forms, that is chi-square test for goodness of fit, which is usually used to determine whether the observed frequencies are in agreement with the expected frequencies. For that we have a example where a random sample of 60 goats were introduced to 5 different fixed commodity or rations. The goats had a free access to all these 5 categories. The preference for the ration was measured by the number of goats eating from a particular bin at any feeding time. So we have a question, or rather what we have to test. We have to test at 0.05 level of significance, which is alpha, if these different types of rations are equally preferred. So the null hypothesis here that all these different 5 categories are equally preferred, and alternative is that they are not equally preferred. So we have a data set out of 60 number of goats, 9 preferred A, 13 preferred B, 14 preferred C, and 11, and similarly 11 preferred D, and the remaining 13 preferred E. So under the null hypothesis, obviously since the number of goats is 60, so the expected number of goats favoring each category is 60 upon 5, that is 12. So this is a fixed expected frequency for this. So in order to proceed, what we have to do, we have to use this table to get the expected frequencies. Since expected frequencies are already calculated here, it is 12, because the expected number of goats favoring each ration is 60 upon 5, that is 12. So the expected frequency for all these categories are 12. Then we need to get these are observed values, and now these are expected values. Since the formula is already the summation of observed minus expected whole square upon the expected values, so the thing is that we have to deduct both these values. That means observed minus expected, then press enter, then we will drag this, and similarly we have to get the square of all these values raised to power 2, press enter, then again what we will do, we'll drag it up to this. Then very quickly what we will do, we will use this is equal to this divided by the expected frequencies. So again we will drag it up to this. Okay, then what we will do, we will use this sum function to get the chi-square value, which is in accordance with the formula here. So we have a chi-square value that is 1.33 almost. We'll write here the chi-square value is 1.33, or we can simply copy paste it like this, Control C, then paste spatial option. Okay, values, I will drag out my camera here. Then what we have to do, we have to get the degrees of freedom. Since the total number of categories are 1, 2, 3, 4 and 5, so we have similarly C minus 1, that is 5 minus 1 is 4. Now how to get the p values for this number of degrees of freedom and for this calculated chi-square, so that we can make a decision whether to accept the null hypothesis or to reject the null hypothesis. To accept the null hypothesis, that means all these 3 categories are equally preferred, or 3 different types of feeds or 3 different types of rations are equally preferred. For that we need to have to get a p value Based on that, we will make a decision whether we are able to reject this hypothesis or to accept it in its own form. For that, we'll be using the function dis.rt, then the value of the chi-square, comma, the number of degrees of freedom is 4, so we have a p-value here, that is 0.88. Well, based on this p-value, which is very high in comparison to the p-value, standard p-value, which is usually we say the things are significant, or in this case we can say all these 5 different categories are not equally preferred, are differently preferred, but in our case the p-value is greater than, rather very high in comparison to the standard p-value, that is 0.05, and the thumb rule is if any p-value is less than 0.05, the things are considered to be significant. So we have to reject the null hypothesis, whatever the hypothesis we have set. But in this case the p-value is very high. That means there is a very important saying, when p-value is high, the null hypothesis will fly. That means it will keep as such. If p is low, then null has to go. So it is a very famous quote. So here in this case the p is very high, so the null in this case will fly, it will remain as such. So the rations are not, or the rations, or the 5 different categories of foods or the feeds are equally preferred. Now the another thing is that we will use this function chi.test. For that, since we have already calculated the actual, we have these actual values or observed values, comma, then we will take these expected frequencies in this case and press enter. Again we can verify this, we have a p-value. Then we'll be using this chi-inv function also. For that we will set a probability value, then followed by the degrees of freedom 4, so that we will get the tabulated value. Since we have calculated the chi-square, so we'll enter, so we have a tabulated value here. Since this 1.33 is our calculated value, since when we are doing the test of significance or doing the testing of hypothesis or that kind of thing or that kind of stuff, the thumb rule is whenever the calculated value of any test of significance is greater than its tabulated value, then we have got some evidence to reject a certain kind of a hypothesis, or rather we can say we have got an evidence to reject a hypothesis. But in this case our calculated value is very less in comparison to the tabulated value, and that was already cleared or evident from the values of p-value, whether we are going to accept or reject the hypothesis. So in our case the calculated value is less in comparison to the tabulated value, so we don't have got any evidence to reject the null hypothesis which says the rations or the 5 different categories of feeds are equally preferred among these 60 animals. So in this case we cannot reject the null hypothesis, we have to accept in this own form. So to make a decision we have to compare the value with the tabulated value of chi-square, which is 9.48 at 5% level of significance with 4 degrees of freedom. Since calculated value is less than the tabulated value, so we conclude that the rations, the 5 different categories of feeds or 5 different categories are equally preferred, and the distribution of animals or the goats among these 5 categories is uniform. So we don't have got an evidence to reject the null hypothesis, so in this case we will accept the null hypothesis. So this was a very brief or a short video about the goodness of fit. In next video we'll be doing another important aspect of chi-square to test the association or the dependence among different attributes. For that we'll be using the another form of chi-square. Hope you like this video. Thank you very much.